All right, so for today, in terms of our circle equations, we're going to talk just about the standard form of our circle equation. And the standard form of an equation is given in terms of the coordinate plane. So we'll have our x and y still. We have x plus our y. And that's going to equal something a little bit different this time. For our circles, there is always going to be a center of our circle. And we're going to use the point HK. That is the center of our circle. And the other thing important for our circles is the measure of the radius. So we have our hour, which is the radius. So HK and R all need to go in here. And the way that they go in here is we're going to have x minus h. So we subtract off wherever the x location is for the center of our circle. We're also going to subtract off the k from the center of our circle on y. We square both those, and that actually equals r squared. So we have x minus h squared plus y minus k squared equals r squared. So let's just try and identify some of the parts for our circle. If I have x plus 4 squared plus y minus 2 squared equals 25. Well, there's a couple of things. First thing I want to do is note that my original equation says that I am minusing these things. So when I see something that's a plus, I'm going to take the opposite of that. So the opposite of plus is minus, and I have 4. So that tells me for my center point, the x part, or the h, is minus 4. For y, I see that this is negative. The opposite of a negative is a positive, and k is 2. So in this case, we have a positive 2 for the y point in our center. So let's go ahead and plot that. We're going to go over 1, 2, 3, 4 to the left for a negative 4, and up 2 for the center of our circle. The next thing we need to do to make our circle is to find the radius. And we said for our equation, the last part, r squared, is our radius. So we have 25. So we're going to take the square root of 25 to get r. And we know that 25 is a perfect square. Square root of 25 is 5. And to make our circle, we're going to count over 5 units to the right, left, up, and down to get our 4 segment points. So 2, 4, 5, 2, 4, 5, 2, 4, 5, 2, 4, and 5. So then we can just roughly connect these parts on our circle. Mine might look a little bit more squarish, but that's okay. Obviously, these do not have to be perfect circles. You can use your compass if you want them to be perfect. I'm not going to be grading on perfect circles or not because we're not in person anyway. So with that, this is the standard form for our circles. You can try out some of these other examples, and I will be posting them on our Schoology page so that you can see if you have done them right or not. When we talk about the standard form of our circle, we should also talk about the general form for a circle. So for the general form of our circle, it's the same thing as our standard form, but now instead of having our squareds with our parentheses, we have completed the square. So we're rewriting by completing the square. So we would write this out as ax squared plus by squared plus cx plus dy plus e equals 0. So now we're going to try out an example by figuring out which way we're going to go here to go from standard to general, general to standard form. So first, converting into standard form, because that's obviously the easier method when we have our general equation. How can I turn that into standard form? Well, the first thing we want to do, if we're given x squared plus y squared minus 2x plus 6y minus 6, first thing we want to do is group our x terms and y terms together. So we're going to have x squared minus 2x plus y squared plus 6y minus 6, but we're going to move that to the right side of the equation. So instead of minusing, we are plussing. So this equals a positive 6. Now, the next thing seems a little crazy. Refresh yourselves on multiplying binomials. So that would be like taking x plus 2 times x plus 1, something like that. In this case, we have something squared. So that means that instead of these being two different things, we might have something like x plus 2 or x minus 4 squared. So what we want to do is we're going to take half of the linear x term and square it. So if I have negative 2 divided by 2 to take half of that is negative 1. And then we're going to square that negative 1. And that gives us a positive 1. Now we're going to add that to both sides of our equation. So plus 1 here, plus 1 over here. What we do to the left, we have to do to the right. So now I have x squared minus 2x. I'm going to put it right in here after my x's because I know that that's the term I wanted with my x. Plus y squared plus 6y equals 6 plus 1 will give me 7. Now we're going to do the exact same thing but with our y term. So this time we have 6. 6 divided by 2 equals 3. And then if we square 3, we get 9. So I'm going to add 9 to both sides. Plus 9 plus 9. And again, I'm going to keep it with the y terms so that I know that's where it goes. And then 7 and 9 would give me 16. So now what we've just done is we've created two perfect square trinomials. That means that I know I have x times plus or minus something squared, plus the same thing with y and squared. So we have to figure out how to factor out these trinomials again. A quick, easy way is to use what I call the x method. So if we have our x method here, we know we need to multiply to get a number and add to get another number. And those numbers come from being the third term and the second term. I need to multiply to get the last number. So we need to multiply to get 1, and I need them to add together to give me negative 2. Well, let's think about what the factors of 1 are. I can take 1 times 1 to get 1. But positives times each other won't add together to give me a negative. So what I have to do is I have to maybe try some options with negative numbers. I know a negative times a negative will give me a positive when I multiply, and in this case, negative 1 plus negative 1 will give me negative 2. So that tells me my factor is negative 1. So in my equation, we would have x minus 1. Now try and see if you can do the factor for y before I get to it. All right, so hopefully you gave that a try. I'm going to go ahead and show you how to do this one again. I'm going to grab a scratch piece of paper here. So if we have y squared plus 6y plus 9. So y squared plus 6y plus 9. I need to multiply to get the last number and add to get the middle term. This comes from when I take, let's say I have anything like let's say that this was actually w plus 5 times w plus 2. I need to use the distributive property to take and multiply w by w and w by 2. W times w would give me w squared. W times 2 would give me 2w. So I have w squared plus 2w. Then I would take and distribute over the 5. I have to distribute over both things to both terms. So 5 times w would give me 5w. 5 times 2 would give me 10. I combine my like terms here in the middle, and I get w squared plus 2 and 5 would give me 7w plus 10. So in order to figure out what this middle term here splits into to get my factors, I'm going to know that I need to multiply my two terms that are on the end together to get a 9. So we multiply to get 9. We add together to get our middle term, because we're going to combine like terms to get 7. I combined like terms to get 6, so that means my factors need to add up to give me 6. All right, let's start listing the factors of 9. Well, thankfully there aren't too many of them. We have 1 and 9, and we have 3 and 3. Well, 1 times 9 does give me 9, but 1 plus 9 does not give me 6. That would give me 10. 3 times 3 does give me 9, and when I add them together, I get 6. So for this example, I have 3 as my factor. And since it's going to be a positive 3, we know that this is a minus 1, or a minus 3. Now, real quick, you maybe have already noticed what I did wrong. Remember that our standard form for these circles is going to be the opposite of our factor. Because our equation is minus, that means that both of my factors in here have to be the opposites. And we said that for x, this was supposed to be a negative 1 in my center. That means that this needs to be a positive to be its opposite. And we said this is a positive 3, so this would stay as negative 3 in there. And we're going to have our 16 on the end. The last thing to note is what our center and radius are going to be of our circle. Well, we know that 16 is actually a perfect square. This gives us a radius by taking the square root of 16, which is 4. So we know that r is 4, and our center is going to be the opposite of these points, or the factors that we just found. Our center is going to be negative 1, positive 3. All right, I know this is tough to go converting and switching through. If we need to do more practice with these binomials and factoring those out, I'm more than happy to help you out. You can always check back in my channel and see some of the other videos where I've practiced and worked through factoring out some of these equations. As always, let me know if you have any questions. See you next time.